Good day, everyone. This is your Sir Balo, and this is just a continuation of our topic, no, from the logical data base design phase, no. And currently now we are at the step 2.2, which is to validate yung mga relations na derive natin from the step 2.1 using normalization. So, I'll just make a quick kasi ito ano na lang to. Na ano natin, we're already familiar with normalization, so I guess I won't be discussing this much in detail. So, in this step, we validate the groupings of attributes in each relation using the rules of normalization. Diba? So, bala yung mga yun nga, yung mga ginawa na derive natin ng relations from this 2.1, bina-validate natin sila kung tama ba or meron bang redundancies doon using the normalization technique that we have learned, no, from previous lessons. So the purpose of normalization, no, is to ensure that the set of relations has a minimal yet sufficient number of attributes necessary to support the data requirements of the enterprise. This was already mentioned, no, sa previous lesson in normalization. Yeah. So, also, the relations should have minimal data redundancy to avoid the problems of update anomalies. So, yun. That is the reason why we are applying normalization, no, to validate, no, yung mga natin, yung mga relations na na-derive natin kung baka may data redundancy or update anomalies doon. So the process of normalization takes a relation to a series of steps to check whether the composition of the attributes in a relation conforms or otherwise with the rules for a given normal form, such as first normal form, second normal form, and third normal form. To avoid the problems associated with data redundancy, so it is recommended that each relation be in at least third normal form. So, yun. And the process of deriving relations from a conceptual data model should produce relations that are already in 3NF. So, take note pag nag-produce ka, nag-derive ka ng relations galing sa conceptual data model, so dapat it should be already in third normal form. Dapat, no? So, dapat there should be no need na to correct. But yun nga, we are applying normalization para ma-validate natin kung tama ba kung yung na-derive natin na relations. Kasi, if, however, we identify relations, logical relations, that are not in 3NF, this may indicate that part of the logical data model and or the conceptual data model is incorrect. So, posibleng pag may na-identify na tayo na relations sa 2.1, no, yung lahat ng mga relations na doon sa 2.1 na derive natin, if may na-identify tayo na hindi naka 3NF, perhaps yung reason dyan is baka namali lang tayo sa logical data model natin, no, namali tayo pag-apply sa mga rules na na-describe natin. Or, posibleng, yung conceptual data model mismo yung mali. Or that we have introduced an error when deriving the relations from the conceptual data model. So, yun. Either na mali yung pag-convert mo, pag-extract mo from conceptual data model to logical, or yung conceptual data model mismo yung mali. So those are the possible reasons, no? So if necessary, we must restructure the problem relations and or the data model, yung conceptual data model, no, to ensure a true representation of the data requirements of the enterprise. So yun. Okay, and next we have validate relations against user transactions. So the objective of this step is to validate the logical data model. And to ensure that the module supports the required transactions as detailed in the user requirement specification. So, bale yung mangyayari sa 2.3, parehas lang sa ginawa natin sa conceptual database design. Pero yung ginawa natin sa conceptual database design na step, vina-validate natin yung conceptual data model using the required transactions. This time, is the logical data model na yung vina-validate natin. No? That kung check natin kung if our logical data model supports the required transactions. No? So, this type of check was carried out in step 1.8, yeah, to ensure that the conceptual data model supported the required transactions. In this step, we check whether the relations created in the previous step also, pag sinabing previous step, this is 2.1, step 2.1. The relations created in the step 2.1 also support these transactions and thereby ensure that no error has been introduced while creating relations. So using the relations, the primary key, foreign key links shown in the relation, the ER diagram, and the data dictionary, we attempt to perform the operations manually. Okay, so bali using sa pag manual, no, mano-manong pag tracing mo sa transactions, no. So you could use the relations, the primary key, foreign keys, the ER diagram, all this even the data dictionary, you can use that, no, para ma-validate kung yung logical data model mo, does it support the required user transactions? Kasi kung hindi, no? If we can resolve all, ito, let's say, kung sakaling okay, no? Lahat ng required transactions, we were able to successfully perform it, no, manually. So, we have validated the logical data model against transactions. So, okay, good. But, if we are unable to perform the transaction manually, kahit isa lang, no, may maano ka na transaction na in which you cannot perform it, no, manually. So there must be a problem with the data model, the logical data model, no, that must be resolved. And next we have 2.4, check integrity constraints. So I guess I'll have to end this video. Hindi pa. I think I still have enough time pa. Kasi itong step 2.4, medyo mahaba din to na topic. Anyway, let's just move on, no? So, integrity constraints are the constraints that we wish to impose, no? Ito yung mga constraints na gusto natin i-impose sa sa design natin in order to protect the database from becoming incomplete, inaccurate, or inconsistent. So, ganun ka-importante yung integrity constraints. A logical data model that includes all important integrity constraints is a true representation of the data requirements for the enterprise. So, we consider the following types of integrity constraints. So, basically, itong mga nakalista dito, this should exist or this should be supported by our logical data model. So, first is the required data, attribute domain constraints, multiplicity, entity integrity, referential integrity, and general constraints. So, pag sinabing required data, no, some attributes must always contain a valid value. In other words, they are not allowed to hold null. No. So, for example, every member of staff, no, na entity must have an associate job position. Let's say, for example, yung staff entity mo, it has a job position attribute. Hindi pwedeng yung position niya is, let's say, for example, yung staff is si Polano. Tapos yung attribute na ilalagay mo yung attribute niya sa job position, yung value is null. So, bali, si Polano, null yung job position niya. Hindi yan pwede. Kailangan meron siyang valid nga value for his job position. So, dapat si Polano should have yung position niya is either supervisor or assistant value niya. So, yun. So, this constraint should have been identified when we documented the attributes in the data dictionary. So, it's from the step 1.3. Attribute domain constraints. Every attribute has a domain that is a set of values that are legal. So, for example, the sex of a member of staff is either M or F. So, the domain of the sex attribute is a single character string consists of M or F. So, ito lang yung possible values or the domain of our sex attribute, M or F. In other scenarios, pwedeng male, female, hindi siya single character but varchar siya, string siya. So, this constraint should have been identified when we choose the attribute domains for the data model, step 1.4. Yeah. Anyway, this is just a review, no? Bale, in the just to go back to what was mentioned dito, no? So, ito lang yung main point ng step 2.4, no? To check the integrity constraint. So, once we have done with the previous steps, we just review. I-review natin ulit yung yung mga natin so far na document natin so far na mga constraints sa required data, attribute domains. It is expected na tapos na to, nagawa na natin to already, and we're just going to review our logical data model, no? Baka meron tayong mga nakaligtaan na mga integrity constraints. That is why we need to again check there are integrity constraints once again, no, sa logical data based design. Nagawa na natin to on the we already achieved this one in the step 1 sa conceptual data model. We just repeat it once more sa logical database design. So, yun yung ibig sabihin lang nito. Okay, so that's why most of the contents that was mentioned here just is basically a review. So, here, going back sa multiplicity, I'm sure you're already familiar with multiplicity. No? So, ensuring that all appropriate integrity constraints are identified and represented is an important part of modeling the data requirements of an enterprise. So, in step 1.2, we define the relationships between entities, and all integrity constraints that can be represented in this way were defined and documented in this step. So, next we have entity integrity. So, the primary key of an entity cannot hold nulls. Yan. So, for example, each tuple or row or record of a staff relation must have a value for the primary key attribute na staff number. Di pwedeng null, ha? So, this constraint should have been considered when we identify the primary keys for each entity type. So, it's from the step 1.5. So, ito yung bago. The referential integrity. So, I think this one, for this type of integrity constraint, I will have to discuss this in detail. Kasi ito, hindi pa natin ito achieve in the previous sa step 1 sa conceptual database design. So, referential integrity, basically it means that if the foreign key contains a value, no? Kung ang foreign key contains a value, that value must refer to an existing tuple or row in the parent relation. So, there are two issues regarding foreign keys that must be addressed. So, first considers whether nulls are allowed for the foreign key. So, here's an example. Let's say we have the following two entities. Yung first entity natin, staff or table, no? Let's just interpret this as a table. So, we have staff table and property for rent table. So, sa staff, we have the following examples na dalawang staff, Manny Pacquiao and Manny Villar. And we have here a property for rent. So far, isa pa lang yung na-insert dito. And this property has the following staff number kasi therefore this staff number is foreign key siya, referencing the staff number of the staff entity. So, bali, lang. Let me just use this one. Okay. So, bali, sabihin nito, this property NG001, since yung staff number nakalaga indicate dito yung value niya NB0, it means that this property, this one is owned by Manny Pacquiao. Itong property na to. Now, ito yung question sa first issue natin, no? Whether nulls are allowed for the foreign key. Allowed ba or hindi, no? So here's the question, no? Can we specify a null staff number? So for example, can we store the details of a property for rent without having a member of staff specified to it? For example, itong pangalawang record, no, or tuple na ano natin, no. Let's say panibagong property, pwede ba to na mag-insert tayo tapos yung staff number, lahat ng attributes niya may value except yung staff number null? Pwede ba to, no? So the issue is not whether the staff number exists, but whether a staff number must be specified. So in general, if the participation of the child relationship is mandatory, let's say since this one is child, no, kasi ang child, pag child entity, automatic yung child may foreign key yan, no? Matic na yan pag isang table or certain relation has a foreign key. Therefore child child entity yan, and this one is a parent entity, itong stuff. Okay, so according here, if mandatory yung participation ni child, in this case si property for rent, so nulls are not allowed. So therefore, kung ano talaga lahat ng properties may may staff siya nga pagmamay-ari or wala siyang null, so nulls are not allowed. But if optional, nulls are allowed. Now, if this is the case, kung allowed natin to, therefore it's supposed to be na dapat yung property for rent optional lang yung participation niya. Okay. So the second issue is we must address how to ensure referential integrity. So to do this, we specify existence constraints that define conditions under which a candidate key or foreign key may be inserted, updated, or deleted. So for example, yung going back sa kanina, one-to-many staff matches property for rent, the relationship, consider the following cases. So first case, insert tuple or row into a child relation sa property for rent. So to ensure referential integrity, we just check that the foreign key attribute staff number of the new property for rent tuple, kasi nag-insert tayo ng panibagong property for rent, is set to null, no, or to a value of an existing staff tuple. Okay, so dapat pag mag-insert daw tayo, no, dapat yung values natin dito should be based from kung ano yung existing dito. Di ka pwedeng mag-insert dito ay let's say yung staff number ng property na to, gawin nating AL03, and since this AL03 does not exist, there's no such staff that has this staff number, so bawal to. We're not allowed to do that. Okay? So yeah. Okay? And the next case, in delete tuple from child relation. If a tuple or child relation is deleted, referential integrity is unaffected. So okay lang. And update foreign key of a child tuple. So this case is similar to case 1. So to ensure referential integrity, check whether the staff number of the updated property for rent is set to null or to a value of existing staff tuple. Yun. So let's say kung going back no sa example. For example, itong NB01, palitan natin to ng panibagong staff number. So dapat since we have here AL02, so dapat ito lang yung pwede natin palitan. Let's say if we're going to update this one, or pwedeng AL02 or pwedeng null. Okay, if we're going to update, take note that this is update, baka malito kayo. In the case where we're going to update the foreign key of our child entity, yung property for rent, so dapat it's a same case lang sa case 1. So either you make it as a null yung value, or dapat yung papalitan mo na staff number, it should be existing from here sa staff natin na relation table. Okay, so next we have case 4, insert tuple into parent. So this one, ito talaga. So this time, let's say mag-insert tayo ng panibagong record or tuple to the staff. No? So inserting a tuple into the parent relation staff does not affect referential integrity. It simply becomes a parent without any children. Okay? In other words, a member of staff without properties to manage. Okay? So kung mag-insert ka ng panibagong staff, so by default wala pa siyang properties to manage. And in this case 5, delete tuple from a parent relation. Now, if a tuple of a parent relation is deleted sa staff, referential integrity is lost. Yun. So if there exists a child tuple referencing the deleted parent tuple. So in other words, if the deleted member of staff currently manages one or more properties. So there are several strategies for this case 5. So no action. Pag sinabing no action, prevent a deletion from a parent relation if there are any reference child tuples. So in our example, you cannot delete a member of staff if he or she currently manages any properties. Okay. So for example, in this one, pwede nating i-delete, tanggalin natin to, burahin natin to si Manny Villar since wala man siyang properties na minamanage. So yeah, pwede. Pero itong si Manny Pacquiao, di natin pwedeng for no action to hindi siya pwedeng ma-delete kasi si Manny Pacquiao may properties siya na minamanage. So yun. Yan yung ibig sabihin nito. Okay? And let's say if cascade, when the parent tuple is deleted, automatically delete any reference child tuples. So if any deleted child tuple acts as parent in another relationship, then the deleted operation should be applied to the tuples in this child relation, and so on in a cascading manner. Well, anyway, for example, let's say kung sakaling i-delete natin to si Manny Pacquiao. So yung mangyayari is all properties that are owned by Manny Pacquiao, in which case itong dalawa na to, they will also be deleted. Ganun yung mangyayari sa cascade, no? If we're going to delete, no? Delete ang cascade, no? Then kung set null, when a parent tuple is deleted, the foreign key values in all corresponding child tuples are automatically set to null. Okay? We can consider this strategy only if the attributes constituting the foreign key accepts null. So bali, let's interpret this first statement muna, no? So for example, ito, pag dinelete natin to, 'di ba, may values to, no? Kanina, 'di ba may values to. Ito NB01. So pag dinelete natin to from NB01, magiging null na lang yung value nito. Okay? Yung bali yung i-replace natin na value from NB01, 'di ba? NB01 yan kanina. Papalitan natin yan into null. ito na yung magiging panibagong value niya. Kaya yan yung ibig sabihin ng set to null. No? And in this second statement, we can only consider this strategy kung yung parent key accepts nulls. So, di ba, na-mention kanina, no? Whether allowed ba yung null values sa stuff. So, kung hindi, di natin to ma-apply. Pero kung okay lang na yung stuff number, pwede tayo mag-set ng null values. So, pwede. We can apply this strategy. We can apply this strategy na set null if accepted yung null sa parent key. And for set default, so parehas lang to, itong set default, parehas lang to with the set null. But instead of replacing the original value into a null, yung original value will be automatically set to their default value. Okay? And for example, pag dinelete natin itong si Manny Pacquiao, and let's assume that all properties are owned by Manny Villar by default. So, pag dinelete natin to, originally, NB01 to, pag dinelete natin yan, pag dinelete natin si Manny Pacquiao, yung original value niya na NB01 will be replaced by AL02. Since, let's assume ito yung default value niya. Kung ito yung default value niya, ito yung magiging bagong value niya. And let's say, kung yung default value is AL03, so yung default value nito from NB01 magiging AL03 din. Ganon lang. Okay? And same sa meron siyang condition, no? We can only consider this strategy if yung foreign key may default value. If yung foreign key mo may default value siya, so pwede, we can apply this strategy. Pero kung wala, so hindi pwede. And then last is the no check. So when a parent tuple is deleted, don't do nothing to ensure that referential integrity is maintained. And 6, update primary key of parent tuple. So if the primary key value of a parent relation tuple is updated, so also mawawala din yung referential integrity. Same with the delete, no? So if there exists a child tuple referencing the old primary key value, that is if the updated member of staff currently manages one or more properties. So paano ba? How do we handle this issue? In the case of cascade, nag-skip siya. Ito lang. Sorry. So to ensure referential integrity, the strategies described earlier sa case sa case 6, case 5, no? This is referring to case 5. So kung ano yung na-apply dito, same goes also with the update, no? In the case of cascade, for example, kung cascade yung pinili mo na strategy, no? Kung anong mangyayari pag mag-update ka ng primary key. So pag sinabing cascade nga method or strategy, the updates to the primary key of the parent tuple are reflected in any referencing child tuples. And if a referencing child tuple is itself a primary key of a parent tuple, this update will also cascade to its referencing child tuples, and so on in a cascading manner. So for example, this one, diba, NB01 yan. Itong 2, originally 1 yan, NB01. So pag pinalitan natin to lahat ng mga NB01 magiging NB02 na siya. So ganon. Okay? And also noting na it is normal for updates to be specified as cascade. So yun, that is why in most cases talaga you're going to implement referential integrity sa update. Usually majority of that is cascade talaga. Depende na lang sa reason mo bakit hindi ka gagamit ng cascade ng strategy. So, yun. And here's an example of a referential integrity constraint for the property for rent relation. So, yung original natin na relation, dinagdagan natin ng state ng referential integrity. Ito yung itong in-underline ko, ito yung tinatawag na referential integrity. Ay, sorry. Dapat ay ito. Integrity. So, in this case, pag mga update daw, cascade. On delete, pag mag-delete, pag ma-delete yung staff number, ay yung staff, a certain tuple from a staff, so no action yun daw. So, yun. Okay, so we have also general constraints. So, finally, we consider constraints known as general constraints. Updates to entities may be controlled by constraints governing the real-world transactions that are represented by the updates. So, for example, the Dream Home, let's say, this is yung company or yung enterprise na or client mo, no? So, for example, this entity, this client, or Dream Home, has a rule that prevents a member of staff from managing more than 100 properties at the same time. So, this example right here, this is an example of a general constraint. Okay? And last, document all integrity constraints. So, document all integrity constraints in the data dictionary for consideration during physical design. So this is referring to the last phase, no, yung pangatlong sa physical database design. Yeah. And then we are at the 2.5, no, which is to review the logical data model with the user. So of course, in the step 2.5, we're already done. Tapos na tayo meron na tayong existing finished na logical data model. And what we're going to do in this step is we're just going to review. Papacheck natin sa client natin kung tama ba yung ginawa natin na solution, or logical data model. So the logical data model should now be complete, fully documented. However, to confirm that this is the case, users are requested to review the logical data model to ensure that they consider the model to be a true representation of the data requirements of the enterprise. So if the users are dissatisfied, kung they feel na parang may mali, no, with your logical data model, then some repetitions of the earlier steps in the methodology may be required. So perhaps you could go back to the 2.1, 2.2, 2.3, or whatever. Pero kung satisfied na siya, so yeah, we proceed with the next step. No? The next step taken depends on the number of user views associated with the database, and more importantly, how they are being managed. So if the database system has a single user view or multiple user views that are being managed using the centralization approach, then we proceed directly to the final step of 2.7. So, we will not be applying the step 2.6 if single user view lang. Single user view. Pero, if multiple yung user views mo, so in this case, perhaps complicated or complex yung database design mo, no? Kasi maabot sa punto na you have multiple user views. So that is why we need to apply talaga this step 2.6. Now this step 2.6, di ko to i-detalye for this lesson kasi will take that's more on an advanced topic na siya. So I guess I have a separate video or lecture for that sa step 2.6, but I'll be describing this briefly. So we're now at the step 2.6, and this is just an optional step. Again, it depends on this scenario, no, in these following conditions. Kung multiple user views, meron ka, if your database has multiple user views, so we proceed with this one. So this step is necessary only for the design of a database with multiple user views that are being managed using the view integration approach. So a local logical database model represents one or more, but not all user views of a database, whereas the global logical data model represents all user views of a database. In this step, we merge two or more local logical data models into a single global logical data model. So, ganun lang. We merge, we combine all those as what I shared you with the first slides. No? Yun. And then last is the check for future growth. Okay? So, logical database design concludes, no? Tapos na, no? Matatapos na yung logical database design by considering whether the logical data model is capable of being extended to support possible future developments. If the model can sustain current requirements only, no, kung yung logical database mo can okay na siya, no, for the current requirements sa current, no, sa kasalukuyan na requirements na kailangan ng client mo, then the life of the model may be relatively short, no, and significantly reworking may be necessary to accommodate new requirements, no. Kasi malay mo, it's possible that the user requirements of your client could change. Let's say for example, within a short period of time, let's say a few months, may panibago na naman silang requirements change, or they have another new feature na i-introduce sa database nila, sa system nila. So yun, that is why it's important na to develop a model that is extensible and has the ability to evolve to support new requirements with konti minimal effects on existing users. So even if it does, it may be prohibitively expensive, no? Kung mag-update man tayo, no, sa will apply new changes sa model natin, perhaps maging expensive siya, no, both in time and money to accommodate possible future enhancements now. So therefore, it may be necessary to be selective in what is accommodated. And consequently, it is worth examining the model, no, to check its ability to be extended with minimal impact. No, konting impact lang na in a way nga hindi makaka-affect masyado sa users mo. No? However, it is not necessary to incorporate any changes into the data model unless requested by the user. So if you feel that there's na kailangan siyang baguhin yung data model mo, pero since hindi pa siya required, like hindi pa siya kumbaga urgently nga kailangan i-update yung logical data mo, so okay lang, stay put lang muna yung ano mo, unless if the time that comes na magre-request man yung users mo, yung client mo, your database or data model should kanang adjust to the new changes, to the new requirements, no. So yun, that's the only time that you can talaga update your or modify, enhance your model, your database. Okay, so at the end of step 2, the logical data models is used as the source of information for physical database design, which is described in the following 2 chapters as step 3. Okay, steps 3. So yeah. So bali ang physical database design, that is step 3 na siya. And the physical database design, this is what we're going to discuss in the next video soon. Okay, so I guess that ends this video lecture about logical database design, and thank you for staying for this very extensive video lecture. And that's all, and see you in the next video, which we're going to discuss physical database design. And thank you for watching, and see you in the next videos. Bye bye.